In this video, we're going to be solving 1- and 2-step equations. So I have an example written there. By the end of this, we will absolutely be able to solve that. As we're solving, our goal is going to be to find the value of x that makes the statement true. So let me give you an example of that. If I just give you an expression, 2x plus 1, x could take on any value. But if I make this an equation, and I say 2x plus 1 equals 5, well, now there's only a small possibility of what x could be. In this case, x must be 2, because when I plug in 2, right, 2 times 2 is 4 plus 1. That makes the left side of the equation equal to the right side of the equation. They have the same value. Whereas if I chose instead to replace x with 3, that's not a solution because it doesn't make the equation true. 6 plus 1 does not equal 5, right? We know that 7 does not equal 5, so it's just as true to say that 2 times 3 plus 1 does not equal 5. In order to solve equations, we need to know our inverse operations. Inverse operations, you can kind of think of them as opposite operations, and they are used to undo the operation that you see in the equation. So for example, addition and subtraction are inverse operations, and we will see an example. So we can see in our example, x plus 7 equals 10, that I see addition, like addition is happening to x. The inverse of adding 7 is to take away 7 or subtract 7, because positive 7 minus 7 results in 0. So I get really kind of an intermediate step here. That's x plus 0, but we never write that because x plus 0 is just x, right? You're not adding any value by writing 0. So we just say x equals 3. Same with our next example, x minus 4 equals 12. What I see there is subtraction. The inverse of subtraction is addition. So I'm going to add 4. Negative 4 plus 4 is 0. And that helps us to isolate x or get it by itself. And 12 plus 4 is 16. So we end up with x equals 16. Similarly, multiplication and division are inverse operations to each other. So let's take a look at some of those examples. Okay, we have 2 examples here. The first one is 3x equals 18. So I'm saying what's happening to x? It's being multiplied by 3. The inverse of that, or the opposite of that, is to divide by 3. And the reason that is because when I do 3 divided by 3, I get 1. So this can be written 1x equals 6. But that's again one of those things we don't typically write 1x, because writing x without the 1 means the exact same thing, and you have to write less. If I go over to the next example, x divided by 10 equals 4. So even though it's written in a fraction here, it still means division. So this is x divided by 10. So in order to undo that division, I'm going to multiply by 10 on both sides. All right, so I can rewrite the left side to be 10x over 10, and 4 times 10 is 40. And then same reason as before, when I do 10 divided by 10, that results in 1. So what I end up with here is x equals 40. Okay, I have listed the steps to solve any equation, but we're focusing on 1 and 2 step equations today. So the example we're going to look at here, there's not any groupings to undo. So we're actually already done with that step. Same with combining like terms, that's going to come a little bit later. In our example here, we don't have to do that yet. Next up, it's step 3, so I'm going to rewrite this a little bit closer. 3x minus 8 equals 31. We're going to add and subtract on both sides in order to isolate x. So notice x is being multiplied by 13, and 8 is being subtracted from x. So we're going to start off by undoing the subtraction using the inverse operation. So I will add. And I end up with 13x. This is eliminated because it adds up to 0. And 31 plus 8 is 39. So 13x equals 39. I don't see any more addition or subtraction happening to x, and so I'm done with step 3. I do still see multiplication on x, 13 times x, so I'm going to use the inverse operation, division, and divide both sides by 13. Thirteen divided by 13 is 1, so I've accomplished getting x by itself, and 39 divided by 13 is 3. So I have x equals 3, and those are the steps you can take to solve any equation. Let's take a look at 4 examples before we finish up. Example 1, x divided by 6 equals negative 2. I'm going to multiply both sides by 6, and I get x equals negative 12. And that's it, I've isolated x. Example 2, 6 equals 9 plus x. I will subtract 9 from both sides of the equation, and I get negative 3 equals x. So it's okay to get negative answers. In example 3, it looks like we're adding on to n, but because the 5 is negative, if I want to make that into a 0, like adding 0 to n, I'm actually going to add 5. So plus 5 to both sides, because negative 5 plus 5 is 0, and that's what gets me n by itself. So n equals negative 1. Again, negative numbers are absolutely perfect. And lastly, if I have 6x equals 40, I see multiplication. The inverse operation is division, and I get 6 divided by 6 is 1, so I have isolated x. 40 divided by 6, well, that's not going to be a nice number. We can write it either as 6.67, rounding to the hundredths place, or simply simplify that fraction. So 40 and 6 are both divisible by 2 to reduce that to 20 over 3.